And today's event is going to be a little different. We're going to be talking about blockchain, something pretty new. And the way this event is going to be organized is Raymond is going to be talking about his presentation on blockchain, and Jason will then talk about distributed machine learning. So it's broken up into two parts. And then at the end, we'll have a small Q&A session. So if you have any questions, leave them in the comments. Other than that, I'll pass the baton to Raymond. Go ahead.
All right, thanks, Randy. All right, let me share my screen. Do you guys see it okay? All right, so today I'm going to do a talk, introduction to blockchain. I know this is usually a data science group, so I'll try to be basic about the blockchain. And a little background about myself. My name is Raymond Fu. I'm a blockchain architect, and currently I'm working with a project called MOAC. It is a public blockchain that is released in April 2018 this year, and we're trying to build a public blockchain basically. So this topic will be basic, but towards the end it'll get a little technical. So hopefully you guys can get something out of it. So let's go ahead and get started. And a little rundown of the content. I'll introduce to you what is blockchain, and then I want to tell you the growth of blockchain from the beginning. So blockchain 1.0, it is the Bitcoin. Blockchain 2.0, which is the Ethereum, and blockchain 3.0, there are a lot of competitors. And I want to explain to you the challenges, and then I want to propose some solutions. All right, so hopefully it'll take 30 to 35 minutes. So what is blockchain? I hope this is something what you can learn today is something that you can tell your mom if one day she's asking you, hey, what is blockchain? And as a younger generation, you need to tell her what it is in very simple words. So let me try to use simple words to explain what a blockchain is. Blockchain is a shared ledger maintained by multiple computers. It is just like a counting book that keeps all the transactions of who's paying money to whom. All right. So you can think of the blocks as pages of a book, and all the pages connected together, they become the blockchain. So every computer keeps an exact copy of the book, which is blockchain, and it can be easily verified. Therefore, all the transactions on the blockchain should be traceable and unmodifiable. So that's very important. And that means you can trust that everything on the chain is trustworthy. It is more trustworthy than a centralized bookkeeping entity, such as a bank. Since blockchain is a shared book that every participating computers can write to it, at the same time, all copies of the book have the exact same, we need to make sure only one computer can write to it at the same time. So how do we do that? That is reason we have blocks. So every time one computer will create a block and write to it, and then everybody else will just make a copy. And then they move on to create the next block. Now, who should be the one to create the block? The question is actually leading to two concepts, the mining and the consensus. So you've probably heard a lot about mining. Mining Bitcoins, it's like making a lot of money. Mining is a process for all computers to compete to have the right to create the next block. Why? Because whoever creates the next block will be compensated. They will all try to solve, the way they do it is they try to solve a math problem that will take a lot of time to calculate. And the first computer who solves the problem will decide on the next block. And then everyone else must agree to it and make a copy of it, attach it to its own local blockchain, and move on to mine the next block. So the blockchain is the same on every node. The rule that everyone agreed upon is to generate the next block is called the consensus, right? They achieve this consensus by doing the mining work. That is why the name of the consensus is called proof of work, or POW. This is a concept that we should constantly refer to in the blockchain theory. So in order to keep all the computers work, you agree to the consensus. Of course, we have to compensate them. We have to give them some incentives. And the way it works is that everyone who creates a block will get some compensation, and the compensation is called Bitcoin. And the very first you can consider the reward. It's a currency that is created by the blockchain system, and it can be used on the blockchain system. So all the transactions are actually a transaction of the Bitcoin, and it is a transfer of values from one node to another. So Bitcoin is actually the very first application implemented with blockchain. So let's move on to a little bit about Bitcoin. So Bitcoin is 1.0, and you hear a lot of hypes of Bitcoin. Why is there hypes? Why is it so expensive? Why people are so crazy about it? Because if you look, the reason behind it, you can have your own reasons, but I believe that everybody believes in this blockchain Bitcoin system is because if you look at the technical implementation of Bitcoin, it's a very innovative technology, and it is truly a revolution. So let's do a rundown of all the technology that is used in Bitcoin. First of all, it created a peer-to-peer network. So all the nodes in the world can use. This is nothing new. It is used to create the foundation for blockchain or Bitcoin. And then it created a shared data repository. That is the blockchain. So the data is written to the block, and the block is chained together, creating a data repository. And then the third one, a tree structure where data can be easily verified. I don't want to go too much into the detail about this one, but basically the data is stored in a block in a Merkle tree structure. And with that structure, the data can be easily verified. That way, if you go back and verify transactions in the history, it's very easy to do. And then Bitcoin's created a method to select a leader among multiple nodes. That is the mining concept we just talked about. Proof of work consensus, that is the consensus that we're using to keep Bitcoin running. Bitcoin has been running for 10 years. It started in 2010, and it's still running. And the proof of work consensus is working for all these years. So people are talking about, the blockchain, the Bitcoin system is using a lot of energy to make it work. But think about the value it's creating. The human being is now creating a consensus without war, without battles. It's just use the electricity. So the trade-off is actually not that bad. Next, what is used in the Bitcoin blockchain is the asymmetric cryptography, and that is used to create accounts. So what is asymmetric cryptography? It is that we can create a pair of keys, a public key and private key, and the public key is something you can share with other people that can be used as a account number or your address. And then the private key is the key that you can use to access whatever is on the address or in the account. That way, you know everything that is associated with your address is safe. Your Bitcoin saved in your address is safe. Last but not least, it is a new currency that is created by Bitcoin. And Bitcoin is the very first cryptocurrency because we're using cryptography. We call it cryptocurrency. Bitcoin is the very first one. And why? How much does it cost? The very first time that human being used the Bitcoin to buy something is on May 22nd, 2010. Somebody spent 10,000 Bitcoins to buy a $25 worth of pizza. And today, how much does it cost? Over $6,000 per Bitcoin. And actually in December 2017, it almost reached $20,000. So that is Bitcoin. And Bitcoin is blockchain 1.0 because it's built with Bitcoin. We created a brand new financial system, a mechanism to transfer values on a decentralized platform. All right, moving on. Limitations about blockchain 1.0. Of course, the biggest limitation is it used a lot of energies. And the picture I'm showing here is actually a mining farm of thousands and thousands of mining machines that's running a useless math problem that is very calculation intensive. It uses a lot of energy, a lot of electricity just to create a block that is used to keep track of all the transactions. So mining is definitely the biggest problem. Proof of work is the biggest problem. And then the second limitation of Bitcoin is it's slow. Today, every second we can only process 7 transactions. That is way too slow. All right. So moving on, I want to talk about blockchain 2.0, which is Ethereum. So what does Ethereum add to blockchain is that it implemented a smart contract. So what is a smart contract? You can think of that, in Bitcoin, A can give money to B, and then B can give money to C, and then that's it. But in the real business world, there should be more. When A gives B some money, they want to do something. For example, I pay you deposit, and if I do something bad, then B should take some a portion of the money out of the deposit, right? So that in the real world, the two people will write a contract. But in blockchain, on Ethereum, you can program that, and you can let one person to put a deposit in, and if they break the contract, the money will automatically go from the deposit to whoever needs to get the money. So that is called a smart contract. So things we can do with smart contracts is that we can create user agreements, we can implement accounts that multiple people has to sign something for the balance transfer to begin, and then we can store more information about the application. So basically, Ethereum is enabling the blockchain to do more complicated business processes other than just a money transfer. So blockchain 2.0, it created a brand new trust system. From a financial system, we created a new mechanism for trust system. So that is what Ethereum has done. All right, moving on to blockchain 3.0. By the way, we will have a session for Q&A. You can ask your questions towards the end of this talk. But let me just go over and talk about everything together. Blockchain 3.0, we have a lot of competitors. A lot of people, they see the success of Bitcoin and Ethereum. They want to make it work for a lot more business cases. They want to make it more flexible, and they're competing for it. So let's talk about what are the challenges and what are the solutions that's out there. First of all, energy saving. I've talked enough about this. Proof of work. We have to have millions of computers running a calculation to figure out the next block, which is using a lot of energy. So one solution that was out there is to do proof of stake. Instead of doing calculation, proof of stake will ask all the nodes to put in a bond on the contract. And then whoever has put bond on the contract can decide on the next block. And then have the vote for other people's block. That way, the decision making is changed from a mining process into a bond required decision making. And in that way, if you make any mistake, you're losing your bond, you're losing money. So that way, everybody, because they have already put bond in the system, they have to work together to make the blockchain the same. So the POS is the way to solve energy saving. Then moving on to the next one, architecture improving. Let's see. I have a slide here to talk about that. Every technology, when they develop from the very foundation moving up, they need to have more complicated, more layered software architecture. And on the left-hand side, you can see that we have infrastructure. On top of that, we have platform, and on top of that, we have software. So thinking about software we're using today, we use Windows and Linux or Mac. Those are operating systems. That is the infrastructure. And then that is the operating system is something that makes you interact with the computer a lot easier. And then on top of that, we have software. For example, we have a PayPal, we have Salesforce, and all types of software that make it your life easier, that'll solve your problem. And in between, we have the platform. And this is a hidden layer, and it's more about a development methodology for you to, for people to easily build software that will interact with all kinds of operating systems or infrastructure. So this is the common multi-layer software architecture in today's world. However, in blockchain, we don't have that yet, right? So today, a lot of the applications or the software will have to build a blockchain themselves. It's just like a mobile app will have to develop their own database, or a car manufacturer have to create their tires themselves. So that's not efficient in the industry world today. So in the future, the blockchain world will be like the same. And I listed out some examples here. On the bottom here, you have all these infrastructures. You can call them public blockchains: EOS, NEO, MOAC, Quantum, Eternity. And on the top, we have software, Ambrosis, Poet. They're solving some real business problems. And in the middle, we have the platforms. The platforms will work with multiple infrastructures, and then they support different kinds of software. So this is a multi-layer architecture that is missing in the blockchain world today. And that is something, the blockchain 3.0 is going to solve. All right, so those are the two challenges, and I saved the hardest for last, the poor performance enhancing. So what is the biggest problem of blockchain today? It is performance. So well, let me just list some of the problems that's out there. Today, blockchain process is very slow. For Bitcoin, we can only process 7 transactions per second. For Ethereum, we can only process 25,000 transactions per second. And what about Visa? Visa can process 10,000 per second. So we can see there's a huge gap there. So why can't we make blockchain faster? In order to talk about performance improving, the triangle of impossibles, which is the picture here on the right-hand side. And I listed out security, scalability, and decentralization. And what is the triangle of impossible? The triangle of impossible, the theory is that no blockchain can achieve all 3 of these. They can have scalability, decentralization, and security all together. So what Bitcoin is doing is Bitcoin is sacrificing some of the scalability because they want to have the decentralization and the security, right? And that's why it's slow, but it's very secure. And it's decentralized. Same thing goes to Ethereum. And some of the solutions like EOS, they are actually using 21 nodes to make the decision to produce the block. And it's faster. The scalability is definitely higher. Security is still high, but they're losing the decentralization. So these are the problems that we have to solve. There are problems. There are solutions that will compromise in one of these 3, but eventually it's going to create a blockchain that improves on the total of all 3 aspects. And these the solutions on the left-hand side, we have sharding, we have side chains, and we have subchains. So these are the 3 categories of solutions that we can use to improve a blockchain. All right. So sharding means we can have, for example, today on the blockchain, every node works the same. If you have a transaction, if you have a contract function call, all the transactions will have to go through all the nodes. And if you have 10,000 nodes or 20,000 nodes, it's the same. Every transaction will go through them. And that's actually waste. A lot of times we don't need to have 20,000 computers to verify my transactions. So what do? One of the concepts we are using here is sharding. Sharding means we divide those 10,000 computers into 10 groups. So we will have 10 shards of nodes. Every shard have 1,000 nodes. And by doing this, and then we can assign transactions into these 10 shards. So each shard can do some transaction, and other shards can do their own transactions. So if a blockchain is able to process 25 transactions per second, if we divided that into 10 shards, they can do actually 250 transactions per second. So that is one solution to improve the performance of blockchain. And of course, there are problems because the communication between shards is always a problem that all sharding solutions should take care of. All right, so that's sharding. The second solution is sidechain. What is the sidechain? Sidechain is actually a network that runs in parallel with the blockchain. So you have all your data, you balance transfer your transactions on the blockchain, and then you have something that's running off the blockchain, but at the same time, you're running it alongside with the blockchain, like it's a sidechain. So what is a sidechain? Let me give you an example. For example, company A and company B, they are doing businesses. They are doing a lot of transfer of money and funds every day, and they can run that on a blockchain. And if they do that on a blockchain, it's very slow, and then the cost is very high. So they decided that the CEOs of two companies talk to each other, say, hey, since we're doing all these transactions together, how about we just do it off the book? We do it off chain, and then we settle it with the blockchain by the end of the day. Actually, that is something we do in the real business world today. Is that a lot of the companies, they can transfer funds to each other, and they only settle it with the bank by the end of the day or by the end of the week. So that is the concept of the side chain, is that two nodes can create another channel for them to transfer fund, and it is off chain, but periodically they will have to settle the balances with the blockchain. And by doing that, because the side chain is not running on the blockchain, it can run a lot faster. And then of course the limitation is that the transaction is not running on a blockchain, right? So there is always a target for any attack. So the third solution is a subchain solution. So what is the difference between a subchain and a sidechain and a subchain? Sidechain is not a blockchain. It is just some services that's running on a network that's parallel with the main chain. But subchain or child chain is an actual blockchain. The way it works is that because if everything runs on the main chain, it's gonna make everything run slow. And we know in Ethereum or Bitcoin today, everything runs on the main chain. And if we have a process that is a game that uses a lot of smart contract on the chain, or we have a financial product that's doing financial transfer on the blockchain, they will be all running on the same chain. However, in real world, they don't care of each other, and the financial product don't care the gamers, and the gamers doesn't care about the financial software users. So the subchain is a concept of using different a blockchain that grows out of the main chain, but it's used to support a different problem. And basically, it will create a blockchain for an application. So that is the concept of subchain. All right. So I think all the three solutions are really good. It'll supplement the existing blockchains, and maybe one day they will become so popular, and some of the project will become a very good solution and popular solution in the future. So that is the way to improve the process of the blockchain. And And then next, I want to give you an example of how the blockchain 3.0 project is going to improve project. Since I work for the MOAC project, I understand this concept very well. So I'm going to use that for example, but I'm not biased. I think, I'm open to all kinds of solutions. So let's take a look at the MOAC. The MOAC is actually using a subchain approach to solve the performance problem. And what it does is it has multi-layers. And the bottom here, as you can see, everything in green, you can treat that as the main chain. All the main chain is running on a P2P network. They talk to each other, and then they're doing POW. It's still using the energy inefficient mining to maintain the integrity of the blockchain. The reason why is because POW is the only proven process, way of doing the only working consensus at this point. And then the way that MOAC works is that it'll create subchains. Every subchain here, the green buttons are the subchain nodes, and they're running a small blockchains on top of that as well. And the way it works is it's going to divide the transactions into balance transfer transactions and contract function calls. As we all know, balance transfer is easy. A gives money to B, and that is easy to process. But contracts may take longer. For example, if there's a complicated logic behind each function call, then it'll take a long time to do. So the way MOAC designed this subchain architecture is that every contract will have its own chain. That way, the contract that supports the gamers and the contract that supports the financial product will not interfere with each other. They will run happily together because they're on different chains. Now, since they're on different chains, how can we make them interact with each other? That's why we have the main chain. So the balance transfer is still on the main chain, and periodically the subchain will have to flush all the status of all the contracts and all the accounts and addresses onto the main chain. That way we can maintain the integrity and security of the subchain. So in another word, MOAC is using the subchain to achieve the sharding solution, because you can think of every subchain is a shard. And also, by the way, the subchain nodes you can share. Each subchain node can support up to 10 subchains. So we don't need millions and millions of nodes. If we can have a decent 10,000 nodes in the real world, it can be used to solve a lot of the problems. Probably all the applications that's running on Ethereum MOAC chain should be able to support. So and of course another thing is every contract, it runs differently, right? So some contracts takes longer to run, some contracts runs more frequently, and because of the nature of the contracts, if they work together on the same chain, it's going to slow down the whole process. That's why it is divided into multiple chains, and then the different types of contracts can be running on different subchains. And because the design of a subchain, this is actually instead of a scale up solution, it is a scale out solution, because you can virtually have unlimited subchains that is rooted onto the same main chain. So that is one solution that we use to solve the problems. And although this is just one project, but I think the concept is used in many other projects as well. And we were looking forward to see some of the new blockchains that's coming out. Hopefully one of them or a few of them will become the next generation blockchain 3.0 that will solve all the problems we talked about here. That'll be energy efficient. It'll support the multi-layer architecture, and it'll improve the performance. So yeah, that's blockchain in the introduction to blockchain in a nutshell. And I realize it's probably a little bit too technical at the end, but I hope if you guys have any questions, we still have time for you to ask and I'll do my best to answer it. All right, Randy?
Yeah, thank you, Raymond. That was great. All right, so the next half, I'm going to pass it on to Jason, and he's going to talk more on distributed machine learning. So that'll be for about 15 minutes, and then in the end, we'll save all the questions. So get your questions ready. We're going to have like a small Q&A session for you guys. So, and Jason and Raymond would answer accordingly.
Thank you, Randy.
Right.
Thank you, Raymond.
Yeah.
Let me share my screen. Can you see my screen there?
Yep.
Is that still good?
Yeah.
Okay.
Yep.
Cool. Yeah. Thank you, Randy. We hosted a lot of online workshop about data science, artificial intelligence, and also big data, machine learning. So today, I would like to talk about some research work we are working on about how we can do the machine learning on the top of blockchain. So it's an introduction about distributed machine learning on blockchain. Let's see. I believe a lot of our students still already know the machine learning. Machine learning is basically a mechanism that we build a function to do prediction, to do classification. So the general concept is we will have a data, right? We feed the data into a machine learning algorithm, and then we calculate the error between the output, the actual output, and the expected results. And then we feed back to the learning process, and we do some adjustations. And then we, finally we got a result. So all the process is running on one machine. That is, the current machine learning system. And for the machine learnings, we have different, type of machine learning. We have a supervised. That means, all the data set has been labeled properly. We have unsupervised. And also we have some other special learning system, just like a recommendation system. We use that a lot at Amazon, Netflix, to do give our users, the books, the movies they would like. And for the applications, you will see, we use a lot of regressions for the prediction. We use classifications for. Here I listed, spam and non-spam, emails. And also we use classification a lot in user segmentation. When we working on our, promotion plan, we will do user segmentation. And also clustering in the unsupervised machine learning. We also use that a lot in user segmentation and also social network analysis. Okay. So that's the traditional machine learning. Okay, how about blockchain? Okay, thank you, Raymond. Give us the introduction about blockchain. Blockchain is a decentralized, data storage. Okay, so currently a lot of the companies they build applications on the top of that. Okay, so the infrastructure is you can see it's a decentralized or distributed, data storage system. All the users' data has been stored in this layer. And for the application, a lot of companies, they build, different machine models on the data layer. And also, we build applications on the top of the machine learning model. And so the application can serve our blockchain users and also, contribute, benefit and profit to the blockchain companies. That is the whole stack. So the first layer is the data layer, and then we build a machine learning model on the data layer, and then we build applications using the models. Okay, that is the whole stack. So we are working on some, distributed machine learning prototype to build the models on the top of, blockchain. We use simulators to do the work. Okay, so basically there are three type of distributed machine learning. The first one is we train the models on the top of big data. The basic methodology is we split the big data into small subset, and we put the subset into many machines. And then we train the model. We run the machine learning algorithm on each subset. And then we combine the results together. During the learning process, okay, there's a communication between the training machines and also the learning machines. So you will see a lot of machines had been involved in the whole training process because the training data set is large. Okay. The second methodology we use a lot is training the partial model. That means we split the models into into sub models, and then we train the sub model on each machine. So you will see after we train the sub model, we will combine the model together. So we have the overall machine learning model there. And the last methodology we use a lot is, we construct a learning graph for the distributed machine learning. In the learning graph, we have vertices and also the connections. We also call that edge. So we split the data into the graph, put the data into the vertices, and then we train the model over the large scope of graph. So these are the three basic methodology we use in the distributed machine learning. So on the blockchain, we can use two systems. One is called a data parallel, and also the model parallel. It's very similar with the data. We were talking about we have three methodology there, right? So either split the data into many machines or use submodel in many machines. So on blockchain, okay, so we use the first two. Okay, we can say, okay, all the data, we can train the model, okay, on the top of each node in the blockchain, and then we combine them together. It's called a data parallel. And also we can send the model into different, node on the chain, and then we train the model on each of the node. So very similar with the machine learning stuff. Okay. So Hadoop. Okay, Hadoop is a big data platform. Okay, we use Hadoop system to build a lot of big data applications. And also, Hadoop map reduce can be used into distributed machine learning. What is map reduce? Okay, map reduce is an algorithm to process the large-scale data and also run some data computation on the top of that. So basically, two steps. The first one we call that a map. So in the map step, we split data into many machines. The machine construct a cluster. It's called a cluster computation. Okay. So we split the big data into many machines, and then we run the computation. For instance, we can run machine learning on each small data set, and in the reduce step, we do aggregations. We put all the results from the subset into an overall one. Just like when we do the machine learning, we train the model on a small data set, and then we combine the overall model together in the reduce step. Map reduce is only working for some of the machine learning algorithm. It's not an overall solution, but it's very fast and easy to understand and easy to implement. So some of the machine learning algorithms use map reduce. And the Spark is another distributed big data system. Although Spark offers MLab, that is distributed machine learning toolkits. So we can still we can refer to the training methodology used in Spark in our blockchain. Okay, so you will see in this graph, in Spark system, we partition the data into different split, and we send the data to some executors. The executors is a training unit running on one of the Spark machine. And then we have a driver to supervise and monitor the whole training process, and also combine the learning results into one overall results. That is, how the Spark work on their, distributed machine learning. So we can use the same methodology in Hadoop and Spark in the blockchain system. We run some algorithm on our simulation. It worked perfect. Here I give you one example. It's a very basic machine learning algorithm, k-means. Okay, k-means can be used to do unsupervised clustering, right? So on the left side, that is our data. Okay, k-means will put start points and then do the distance, compute the distance between each node, and then classify the nodes into different segmentations. That is how the k-means is working. When we work on the distributed system, so the data has been saved at a different data node. It either distributed or decentralized. And when we do the k-means, we can, this is the formula, how we can do that. So basically, here we use map reduce. Okay. In the mapper, you will see we calculate one of the data side, and in the reduce set, we calculate the overall. So it's a very standard, map reduce algorithm. And on the blockchain, we can use the same methodology. So here is the algorithm. So on for each of the k-means iteration, we send the computation and broadcast to the worker in blockchain, that is some of the node. And in the map reduce step, we can do the computation on each node, and then we combine them together through a driver. So that is the algorithm we use. And also here is the complexity. So you will see most of the computation happen on the workers, not on the, the central driver. So you will see a lot of, excuse me, a lot of work in our simulation. A lot of work is running on the distributed node. It's not in the central size. Okay. So here is some work we did in the blockchain research, and welcome, any, questions. Randy.
Yeah, thank you, Jason. Thank you, Raymond. Very awesome presentation.
Do you know how I can stop?
Okay, yeah, so we're going to use the last 15 minutes to answer any Q&As. So any questions you guys have, either if it's about machine learning or if it's about blockchain, Raymond or Jason or myself will be more than happy to answer. And to leave a question.
I think I saw an early question about explain more transactions on MOAC.
Okay, yeah.
Right?
If you can read it out and answer it.
Sure. This is for from Chandra Brankesh. Explain a little bit more about MOAC architecture in terms of transactions and nodes. All right, so MOAC main chain is similar to Ethereum or Bitcoin. It's going to process all the transactions. So the transactions will send to the, so if you use any client to send all the transactions to the nodes, it'll be processed, and every node will verify the transaction. And once it's verified, it will be written to the blockchain on the main chain. So that is the transaction. And now for the contracts, in the Ethereum contract is just another transaction that will be processed on the main chain. And for MOAC, it is recommended that you run all the contract on the subchain. Now, we don't force you not to run it on main chain. It's just we use a pricing difference to recommend people to use the subchain instead of the main chain. That way, all the contract will go to the subchain. It might take longer. The frequency may be higher, but it's not gonna impact the main chain. So that is how transactions is on different chains and different nodes. And the nodes for the main chain and the subchain will have a slightly different component installed. So for the main chain we call it V node, and for the subchain we call it the SDS. So it's different programs you need to install if you want to participate. And for main chain you have to do POW. So hopefully you have GPUs installed that can help you benefit from the calculation. And on the subchain, you don't need to mine anything. It's not running POW, so you can actually use any computers as long as you can keep it online 24/7. I hope that explained the question.
Yeah, thank you. And also, I just launched our poll, so give the audience maybe a minute to fill it in.
Okay.
Yeah, so if you guys are the viewers, I just launched a poll for everybody. If you can please just fill it out, it'll take 1 minute of your time. This allows us to actually enhance our webinars and allows us to focus on what you guys are interested in.
Okay, so we are working on the poll. Let me pick up one question. I think some of our students ask, what is the advantage of distributed machine learning comparing with cloud machine learning? So I would like to see, okay, cloud service is all the computation is running on the cloud. It's not in your private network. And I know a lot of companies they put a system called machine learning as a service, right? Just like there's a company called datascience.com. They have a system. So they make machine learning very simple. You put your data into cloud, and then they build the whole machine learning system for you, and they will, use their cloud service, just like a machine learning as a service, to give you the model. So I think that is the cloud machine learning system. And the distributed machine learning is something like when, there are two learning modes. One is you can do the learning on one machine, your laptop, you install R or Python, you train the data. That's on your laptop. It's only a single machine. And distributed is because the training data is too big. You cannot do the training on one machine, so you have to leverage, the distributed system like a Hadoop, Spark, or, currently we can use blockchain or some other, simulators. So that is, parallel. You can see that is a distributed or parallel machine learning. So you will see, cloud machine learning and distributed machine learning, you cannot compare them together because they are different things. Cloud machine learning is just a service. It's machine learning as a service. Everything you can do that on cloud, not on your private network or machine. Either that is a single super server in cloud do the learning, or it's a distributed. Distributed machine learning is the machine learning on the cluster. So I would like to see, the advantage for the distributed machine learning is, it can train large scale data set. Okay. Hopefully, that is the answer to the question. Yeah.
Yeah, Raymond, I have one question for you that's pretty interesting.
Mm-hmm.
So the question is...
Sure, go ahead.
Yeah, so I have a question on blockchain. Who generates the math problems?
Yeah, whoever designed the blockchain generates the math problem. And it's actually a very simple problem. You know what it is? Is that, it's using a hashing mechanism to create. So basically, hashing means you use a string, you use a math calculation to create another string. And in order to figure out a string that can be used to create a block, you need to create a string that's exactly the way that you want. So the rule is for Bitcoin is that you want to create a string that has, say, 6 leading zeros. So this is written into the program. So the designer of blockchain is creating this math problem. So if you do a lot of calculation, a lot of hashing, eventually you will create a number that has 6 leading zeros. And whoever does it for the first will get the right to create that block. And then if more and more people are joining, if you can find that number with 6 leading zeros soon enough, then the program will automatically change it. So you have to find like 7 leading zeros. If less people are running this problem, then maybe it'll change this to like you need to find a string with 5 leading zeros. So all these is written in the program. And of course, different blockchains can have different design, but the people who design the blockchain will create that math problem.
Got it. And there's one more question for you, Raymond, by April. Mm-hmm. So she said, I have a question on smart contracts. How do we track and determine if someone breaks the contract?
Interesting. The contract is actually, the smart contract is a program. Once the program is deployed into the blockchain, it's there. You cannot change it. All right. So if the contract says if something happens that you have to pay someone 20 MOAC or whatever cryptocurrency, then the money will be triggered. You cannot change that. Now, in terms of whether or not you're breaching the contract, that is a business rule, right? For example, if you're paying rent and then let me think what a good business process is. If you're renting out your house and you have a smart lock that is connected with Ethereum. If your tenant is not paying you the monthly rent, then the smart contract can trigger a process, and hopefully that process can be connected with the smart lock you have, and they will lock the room so your tenant will not be able to get in. So I hope that answered the question. It's the concept is that the code is the law. Once the smart contract is written, it'll execute based on the agreement.
Got it.
Right.
And there's about two more or one more. Jason, there's one about distributed machine learning. Do you want to answer that one?
Okay, I see one. Do you have comments on distributed machine learning on more intensive applications such as, massive image and video data? What is the overhead due to the communications time, data transfer time, how the workflow is different from a centralized machine learning model? Okay, so I would like to see if the data set is small. Okay, if you can train the model on one machine, it's okay. You can you can just train the model on your laptop or the super machine on your machine on your school. I know a lot of universities, they have a super machines. You can leverage that to train the model. But in some special case, just like image, video, audio, all the unstructured data set, they are too large to run on single machine, or even you can find a super machine, but it's still too large to do that. So you have to use the distributed machine learning system. But the overhead, the additional cost for the distributed machine learning is, basically three things. First, you have to have, have some code to distribute it, split the data into small data set and distribute it to, the machines on the cluster, right? So you have the data transfer, overhead, and also during the training process, there are a lot of communications between different training node, and also if you have a central node, okay, there's a communication between training node and the central node. Even though you do not have the central node, but still, you will have some communications between, among the training process. That's the overhead. And also, after you do the either submodel or subset, sub-data set, you have to, put them together. So there's another, the third additional job you have to do. So in comparing, single machine, there are a lot of, additional costs for you. So you have to, do the balance, okay? So if you split, too many small data sets, that means, on each machine, you will have a small computation job, but the communications are very large, right? If you split the data into large data set, okay, you will have a fewer computation node. That means maybe a smaller communication, cost, but on each machine, the computation job is large. So you have to balance them. So that is, my comments, for this, question. If you are working on large scale data set, you have to, design the learning system considering, the communications, the transfer, and also the overall performance.
Got it. All right, we have one last question, and this is going towards Raymond. So this is asked by Christine, and she's more curious about the MOAC. She said, can the MOAC be secure enough to prevent a 51% attack?
That is a very good question. That is a very good question. Now, theoretically, no blockchain can be secure enough to prevent 51% attack. Basically, when you have 51% of the nodes, you own the nodes. You can do whatever you want, right? So how can we prevent that? This is more than just a technical question, right? So for MOAC, we actually have about over 1,000 of the nodes out there. So by increasing the number of the nodes, you make it harder for any attackers to gain access to more than 51% of the attack. So for some of the small blockchains, when they first release, they have, say, maybe 30 nodes that's running the blockchain. And then, of course, the attackers can easily gain more than 51%. And another reason the attackers will gain 51% is because they want to get something from you, right? And if the price of your cryptocurrency is not high enough, you know, there's always a cost to access your blockchain and gain access. And if the price of your coin is not high enough, there's no point of doing that. So for MOAC, I think we have a good the foundation. The MOAC Foundation have a good technical strategic relationship with all the miners to make sure we have enough miners that's mining the MOAC. So it won't have more than, it'll have a lot of nodes to protect the system. And we also make sure the MOAC price is there enough to support the miners. So very good question. And I think that opened up the answer, and it's not just technical, it's also strategic.
Yeah, all right. Thank you guys. Thank you, Raymond. Thank you, Jason. And thank you all the attendees. So again, we host these webinars maybe like twice a month. Topics range from blockchain, AI, big data, data science. So it varies. And today was our first blockchain. So thank you, Raymond, for doing an exceptional job.
You're welcome.
And again, thanks everybody for attending. Have a great Father's Day and a great weekend. Other than that, bye guys.
Bye.
Thanks.